Okay, now that we have discussed the difference between the formulas used, which is Sn and Snth, let us now try to understand the question and solve this using Sn first and then Snth. Okay, so the displacement and the increase in the velocity from t to t plus 1. So if you assume this to be the motion from a to b, let us assume the time to be t to t plus 1. And what is the distance covered here? The displacement here is AB, which is, according to the question, 125 meters, right? 125 meters. And the corresponding change in velocity, increase in the velocity is 50 meter per second. So say if you have u here, what you get at b would be u plus 50 meter per second, right? Now, what is acceleration? Would be the increase in velocity over 1 second, or dv by dt. What is dv here? dv here would be final velocity, which is u plus b, minus initial velocity u, which would give us, maybe I should write it over here, should give us u plus 50 minus u upon what is change in time? It should be final time minus initial time. And what is the final time? The final time from the question is t plus 1. So t plus 1 minus initial time is t. And therefore, the value of acceleration would be 50 by 1 meter per second per meter. So acceleration would be 50 meter per second square. Now we have acceleration is equal to 50 meter per second square. Then using second equation of motion, we have s is equal to ut plus half at square. The distance traveled here, the displacement traveled here is AB, which is equal to S, which according to the question is 125 meter. In which case S is equal to 125. Initial velocity is U. The final velocity at B would be U plus 50. Yes, according to the question. So we have 125 is equal to U plus U into t, which is 1. Why is t 1? T plus 1 minus t plus half into 80. What is a? We found out a to be 50 meter per second square. So it is 50 into time is 1. So we have 125 is equal to u plus 25. And therefore, the value of u is 50. Now, according to the question, what we have is at t plus 1, the increase in velocity is 50. So if the velocity at t is 100, the velocity at t plus 1 would be u plus 50, which is 100 plus 50, which is equal to 150. Or you can go for first equation of motion, v is equal to u plus 80. And now we have found out that at b, the velocity is equal to 150 meter per second, right? So for the motion along AB, the displacement is s, right? And the initial velocity is u. The final velocity is 150 meter per second. Now, let us consider the motion along BC. So here the displacement is s. The initial velocity would be velocity at B. Okay, let me just write it down here. So, final velocity for AB will be equal to the initial velocity for the motion along BC. So what is the final velocity for AB? It is velocity at B. So what would be the initial velocity for BC? Initial velocity for BC would be VB. And what is the value of VB? We found out the value of VB to be velocity at B is equal to 150 meter per second. In which case, if we apply second law of motion for the motion along BC, we have x is equal to ut plus half at square. U would be 150. Now the question comes, what would the value of t? Is the value of t equal to 1? Yes, it is definitely equal to 1. But how? Because we've been asked to find out the value at the t plus 2 seconds. So t now would be, final t would be, or let us say t final would be t plus 2 and t initial would be t plus 1. Therefore, what is the value of t? It would be equal to final minus initial, therefore t plus 2 minus t plus 1, which is equal to 1. And in which case, what is s is equal to? Ut plus half at square, u is 150, t is equal to 1, and we have half into acceleration is 50 into 1 square, so 150 plus 25, which is 175. Therefore, the answer would be 175 meter.